Thank you again to the Carnegie Council for hosting us. Thank you, Joe. Welcome to our special guests in the room. Quick reminder to turn off your cell phones. Thank you. Warm welcome to the hundreds of people joining us online from around the world. And another special warm welcome to the many journalists who are with us tonight. I'm sure you'll write fascinating stories about our conversation. No pressure, Glenn and Kathy. Our topic tonight is gene editing. Scientific innovation now allows us to edit DNA quite precisely. This is currently done on animals and in rare cases on patients. But our focus tonight is very specific. We're going to talk about genetically editing the human embryo in vitro following IVF. And I'm not going to get into scientific detail, but it's important to highlight that if you edit a human embryo in an early stage of development, technically that edit would appear in all the cells of the body of the baby that would be born of that embryo, including the sperm or egg. Which means that that edit would pass on to the children, grandchildren, and all the subsequent potential generations born of that baby, which means that you made one edit, but on an evolutionary scale, you possibly had significant impact. And that means that our conversation tonight is, I don't want to be overly dramatic, but about the future of the human race. And this kind of topic really aligns beautifully with the strategic priorities of the Hastings Center. We want to be anticipatory. We want to look ahead, behind the corner, as Joe always reminds me. And we welcome the opportunity to discuss the ethical and social implications of a technology that is not yet available in the clinic. And before we launch the debate, I also want to step back and say something about the broader context of bioethics as a field. I find myself in many rooms as the bioethicist where the perception is that bioethics or ethics in general is always about the why not. It's about the issues, the concerns, the fears, the risks. And I think that bioethics should not preach to the choir, stay in its own echo chamber. It should engage with innovation because there's also a risk in opportunity cost. If we delay innovation, we create delays in the access of patients to important interventions. We must have convincing ethical reasons to delay. And so our conversation tonight is not about why not. It's not necessarily about why yes. It's forward-looking. It's asking whether there's a way forward that could use this technology for reproduction, which is outside the comfort zone of quite a few bioethicists, in a responsible and wise way, keeping in mind that we always need ethically justifiable goals for such use of technology, and that any emerging technology should do good in the world and not just benefit the select few. That is my framing of the discussion tonight. This is the kind of bioethics that we do at the Hastings Center. And this is a public event. We will take questions from those online as well. If you have a question, please type it into the chat function directly to the host of the event. We'll take questions from the room. And at this point, I will introduce our debaters. This is not a strictly technical debate. I will not be counting seconds and counting rebuttals. It's a facilitated conversation that is meant to identify areas of agreement and disagreement. But do keep to your time, Glenn and Kathy. Glenn Cohen is a professor of law and deputy dean at Harvard Law School. He's faculty director of the Petrie-Flom Center for Health Law Policy, Biotechnology, and Bioethics. He is one of the world's leading experts on the intersection of bioethics and law. He's also the person with the best taste in glasses of all of the academics I've ever met. No offense to my colleagues here. Not to mention his taste in shoes that I don't know if the people online can see. Kathy Tai is founder and CEO of Origin Genomics, which develops germline gene correction for preventable diseases under IRB-approved protocols in the United States, a Teal Fellow, serial biotech founder, and board member of Cold Spring Harbor Laboratory. She works at the intersection of frontier science and clinical translation. So my first question to you is not really a question. It's, would you give us some context? Why are you passionate about this technology? Why have you decided to study it, work on it? Glenn.
Okay, great. So to me, this is an incredibly exciting, if you talked about things in my lifetime that I thought would be science fiction rather than science fact, this is on that list. So incredibly exciting. Also incredibly scary in terms of the risks of off-target alterations, for example, the risks to future generations. But also when I think about inherent questions that are interesting to bioethics, what makes us the people that we are? What is the continuity of ourselves before and after an alteration? This forefronts issues of intergenerational justice. What do we owe our children? But also what the appropriate attitude is towards our children as people rather than products. It's complex in that it imposes both possible benefits and risks, and we're talking about future generations who have not consented to either of those things. It touches on very sensitive questions like the values of communities, questions of eugenics, questions about the expressive attitudes we express towards a trait or towards a way of being by the decision about what to edit. And like much of bioethics, this is something born in scandal, in that much of the discourse we have now is in relation to Dr. Zhenkui Hu's experiment in China, what I view as a completely unethical experimental activity that was undertaken, and the world had to react suddenly to that. And as a result, my view is that much of our policymaking in this space is relatively coarse, relatively on-off, and my hope is to kind of provoke a more nuanced discussion of what that might look like.
Thank you. Kathy.
I want to start by acknowledging what this moment is. We're gathered here for the annual Daniel Callahan program, named after the philosopher who, in 1969, looked at the intersection of technology and human life and said that this needs its own field of study. And he was right. Tonight, 57 years later, we're living the question he helped create. I'm a founder. I build genomics tools. I am not a philosopher, and I'm not a bioethicist by training. And I suspect that's actually why I'm sitting here tonight. This debate has always needed the people actually holding the tools to be in the room, not just the people theorizing about them. And while I'm honored, I'm also aware of the weight of this moment, because what we're deciding, not just tonight, but in the years of policy, research, and regulation that follows conversations like this one, is whether our species will use the most precise biological tool ever developed to prevent suffering, or whether we will let fear, dressed up as caution, make that decision for us. When I announced I'd be working on gene editing to prevent disease last year, my inbox is filled up in 2 languages. A woman in Ohio whose mother no longer recognizes her. A father in Shenzhen watching his son lose motor function to a mutation with a known address. A young woman with a BRCA1 mutation who has already buried 2 aunts with the exact same mutation. None of them used the language we'll use tonight. They didn't say, heritable edit. They said, please. 1 year in, and the thing that is already obvious to me is this. There's a massive dissonance between the academic nature of rooms like this one, where this is debated, and the urgency in the homes where this is lived. Somewhere along the way, science has become so granular that while we became really good at studying the patterns in the leaves, we forgot about the tree and the forest. We talk often about the danger of moving too fast. I want to name the danger of moving too slow, and the fantasy of waiting for global consensus, which will not arrive. This is what happens when the people setting the pace of progress are not the ones paying the price of delay. In 2015, the scientific establishment gathered in Washington and said, not yet. In 2018, they gathered in Hong Kong and said, not yet. In 2023, they gathered in London and said the exact same thing they said in 2015. 8 years, 3 international summits, 0 clinical approvals. But hey, at least we got 60-something reports and hundreds of papers. At the end of the day, the Child with Tay Sachs still dies before age 5, and federal funding for this research is still banned to make any progress whatsoever on the safety of this tool, even for the most dire diseases. This is why my one condition for participating in this debate tonight is to have genetic disease carriers in this room with us. So the people this debate is about are in the conversation, not just talked about. It is not done often enough, and it's way past due.
Wow. Follow up to you, Kathy. Your efforts received a lot of attention in the media. What has been the overall reaction? Positive, critical?
My goal with launching my work publicly was simple. It was to be transparent with the press and the public about the work needed to advance this field forward. I essentially said that the most consequential science of this century can be done and should be done, but only with transparency, oversight, and rigor. That is the ethical thing to do, not another 10-year moratorium. The field actually already knows this, and they just rarely admit it, at least for now. 5 years ago, saying anything like this out loud would have gotten you the same backlash that the industry has seen for a decade before that. Then something called mitochondrial replacement therapy, the first form of germline gene therapy that helped correct mitochondria mutations at the egg level, it was called the three-parent child by the media. That wasn't a scientific critique, it was a slogan, and it costed us. Years later, the UK approved MRT, Australia followed, and now in 2026, over 100 children have been successfully born using MRT around the world. Yet the US still bans it. Why? Partially because the slogan outlived the science. There is real suffering when slogans like this go unchallenged. So I set out to challenge this. And the framing actually really resonated. When I went public with this, the reaction was that IVF physicians, scientists, patients, and even some ethicists have said some version of the same thing to me. It was something like, finally, someone is doing it. The honest truth is that people are tired of waiting for progress. It's a paradox. Back in 2015, people said that this technology was not safe enough, so therefore we should ban it. Funny thing is, in 2026, we're having the exact same conversation. Nothing really changed. The paradox is that if we don't work on it, it'll never be safe enough. So breaking that paradox means working on the science transparently and openly, which is exactly what I set out to do with my company, Origin Genomics.
And I will confess that Glenn and I collaborated on a paper to support the implementation of MRT in the US several years ago. So, a point of agreement. To set the starting point for the debate, thank you for giving us context, very eye-opening. To set the starting point for the debate, I want to subject you to rapid fire. I'm going to ask you yes/no questions. In order to sort of focus in narrowly on when...
I feel like I'm on the witness stand. Go ahead.
Not where you used to be.
Exactly.
Are you ready? Do you think that editing human embryos is inherently unethical, that it can never be permissible?
No.
No.
We have agreement. So there is a point where it might be ethically permissible. Let's go more granular. Is it ethical to conduct research on human embryos in the lab to learn more, to improve the safety of this technology?
Yes.
Yes.
Yet again, agreement. Let's dive deeper. Can it ever be ethical to move to a clinical trial and implant an edited embryo to actually have an edited baby?
Yep.
And I also agree.
Well, this is not looking like a debate at all. So let's get into the things you may disagree on. My first real question is this. When do you think it would be ethically acceptable to implant an edited embryo? What case might justify the reproductive use of this technology? And if you will give us an example, what would be the first gene that you would target? For what disease, condition, or trait? Kathy, you go first this time.
I believe that the first use cases should be severe monogenic disorders with well-defined pathogenic variants. These are diseases and genes that current new advances in gene editing can tackle, such as with base editors, prime editors. And eventually, we'll later on move to other diseases, of course, like polygenic diseases or more complex heritable conditions. There are over 7,000 heritable monogenic diseases. Only 5% of them have FDA-approved cures. If I were to name all of these diseases, we'd be here all night, so I'll skip that. But some of them you might recognize: cystic fibrosis, Huntington's, sickle cell disease. And I think from a technological level, and this is something I've been working on very hard at my company, is how do you create a framework from a technology level to validate the safety of this tool at every stage of development? You know, I think first you start with patient iPSCs. You look at the specific mutation that the patients have. You test the newest gene editors against those mutations. You validate by sequencing before and after the gene edit to understand any bystander or off-target effects, any unintended consequences. Then, only then do you move into other IRB-approved research related to patient gametes. And same thing there, you want to do sequencing before and after to understand things like mosaicism, off-target effects, bystander effect, and then later on at the blastocyst stage, which is when the embryo gets to day 5, is when you do something called PGT, which is when you sequence that. Do a biopsy of the blastocyst, you sequence it before and after, and you understand how that gene correction has affected the embryo. So those are the areas of technology research that's applicable to understanding the safety of this tool. But just to reiterate, you would really start with the severe monogenic diseases, which is what we're doing at Origin Genomics.
Thank you. Glenn?
We have more agreement than you might expect, although I do want to be careful here about the way we characterize the bioethical discourse here, and that it's not that everybody is saying moratorium, and that many bioethicists support this idea of serious monogenic risks as a possible use case here. But I want to make sure we're talking about the same things, right? So what do we mean when we talk about a serious disease? I'm thinking very much the way the NASEM and the Royal Society, in one of the many reports that maybe have been put into disreputable light here, but many of the reports recommended would be appropriate for a translational path. And what do I mean? It's a serious monogenic disease that causes severe morbidity or premature death. We should be limiting the edits to changing a pathogenic variant known to be responsible for the serious monogenic disease to a sequence that is common in the relevant population, that is known not to be disease-causing. And I'm not sure this is a place where we agree. It should be an instance where the family in question has no option for having a genetically related child that does not have the monogenic disease. That is to say, we want cases where I think they have no possible other technologies for avoiding this outcome. And I actually agree that Huntington's is a good candidate for this, and as did the NASEM and the Royal Society in this. But it's important just to emphasize why it's a good candidate. Because remember, we are imposing risk. When we go first in human, it is inherently a risky move, and it is a transmission of risk to someone who never has the opportunity to consent, and indeed to many generations who don't have the opportunity to consent. And why it's justified is that the alternative for this particular family for having a genetically related child is something like early morbidity, really severe diseases. So to me, that is the right place to focus our attention.
Thank you. So I want to get even more granular. We recently read in the news about the first gene therapy that was developed specifically to save the life of a baby. Baby KJ was born with a rare genetic disorder and was successfully treated with a customized gene editing therapy by a team at CHOP in Philly. It was a race against the clock to save his life. It cost hundreds of thousands of dollars, but it showed that such treatment can be possible. So my question to you is this. If a condition can be treated by gene editing after birth, do you think it is ethically justified to try the intervention in the early embryo despite these risks that you just mentioned, Glenn? And as a reminder, if you treat the baby, the edit only affects that baby. If you treat the embryo, the edit will pass on to all the potential future generations born of that baby. So the risks are on a different scale. We'll start with Glenn. Somatic is possible. Would you go germline?
So I will say presumptively, and I'll explain what I mean by this, presumptively this is not an appropriate case for heritable genome editing. And why do I say that? Here's why. We're talking about making people research participants without consent. These are future generations, great-grandchildren, great-great-grandchildren, who will be affected by the decisions we make. Scientists, clinicians, prospective parents are making a decision that are going to affect these future generations. And when we have the opportunity to instead ask the people who are going to be most directly affected and giving them the opportunity to make the choice, a choice that's going to affect them and affect their children, we should take that opportunity, which is the somatic edit, when it's possible. Now, to be fair, all acts of reproduction impose risks on the people who are reproduced, and they never consent. Shauna Schifrin has a famous article suggesting that maybe this makes reproduction a morally dicey process, right? But we're talking about reproduction in a kind of a limited way where we kind of know the range of outcomes. This is very different. This is an experimental procedure. And there are differences between reproductive activities by which an individual could not otherwise exist and those that alter the individual to become a different individual. As Jan Narveson said, the reasons to make children happy are very different than the reasons to make happy children. There are two different categories of reasons and ideas that we have to think about. And once again, this is not normal reproduction, but at least at first, an experimental form of reproduction that we should be taking seriously in this respect. So in my view, this makes it fundamentally different than regular reproduction. And we should not be making choices for others, let alone for generations forward, where there is instead a possibility of letting them choose themselves. I think we should be making decisions for ourselves, not decisions for our great-great-great-great-great-grandchildren. Now, I did say presumptive or pro tanto for the following reason. Maybe this view of mine might be overcome if you showed me that the heritable edit was much safer, for example, than the somatic. I could imagine a case, especially if we're talking about things within the serious bucket, where it might make a difference and I might have another look. But overall, I would start with the view that where somatic is available, germline is inappropriate.
Thank you. Kathy.
Seems like this idea of heritability keeps coming up, that this idea that you can do a gene edit at the germline level and it keeps being passed down to generation after generation. So I will take this framing head on because this is where ethical intuition breaks down when you examine it really closely. When parents consent to a gene therapy for a newborn, as they did with baby KJ's case, they're not making a decision that can be reversed. They're making it on behalf of a person who cannot yet consent. And they're making it knowing it will shape that person's entire future existence, in many cases, the health and the lives of the person's future children as well. The somatic therapy that saved baby KJ's life will shape every downstream decision he will ever make, whether to have children, how, with whom. Parental consent has always casted a shadow across generations. That is not a novel feature of germline editing. That is the basic structure of parental consent. So when we're told that the germline gene editing technology is ethically distinct because it propagates to future generations, the honest answer is this. Every parental decision propagates. Every consent they give shapes the next generation. The only difference with germline editing is that the propagation is molecular and measurable rather than social and diffuse. The ethical principle of proxy consent on behalf of a person who cannot yet consent in service of their best interest is actually identical. And when I first heard this question of if the condition can be treated post-birth with somatic gene therapies like the one that baby KJ received, then is it still ethically justified to try the intervention in the early embryo? I thought of like a really simple example, which is Tylenol. You know, there's Tylenol, and there's also Advil, and there's also R&D for other pain relievers, pain-relieving drugs. Should they all cease to exist because we have Tylenol already? No, you can have both. I think both somatic and germline gene editing are complementary. It provides more options for family that suffer from these diseases. And not to mention, somatic gene therapies cost months to create and also months of treatment. Take, for example, the first FDA-approved somatic gene therapy, Castrobee. One, it costs $2 million. Two, it takes 3 to 6 months of treatment. And 3, it's extremely invasive. You have to go through chemotherapy versus an injection that happens at the embryo stage, which is going to be way less than $2 million USD per patient per dose. So I think that both can exist. I think germline gene correction represents an immense opportunity for patients to have more affordable gene therapies and also to correct the mutation when it is the most effective to do so at the earliest stages of human life. And whether or not this is going to be available tomorrow, that's going to be a no. But I think it can be available if we do all the right research to show that it's safe and efficient. And that's the work that the field, I believe, should be working on right now.
This calls for a rebuttal.
Yeah, great. So a point of disagreement, finally, which is good because we are in a debate here, right? So I think there's two places where we disagree. The first is just to understand what a parent-child relationship is like and why it is we give parents sometimes the prerogative to choose for their children. And that is that they have a special kind of relationship, including a commitment to bear the burdens of the choices they make in their child rearing. If your child turns out to be an a-hole, if you'll pardon my French, right, you have to rear that child for a long period of time. That is a facetious example, but it is exactly the same thing here we're talking about. You're making a decision about your child's health, and you, as the parent, are going to live with that decision for your life in a way you will not live with the decision of your great-great-great-great-great-great-great ad infinity grandchild. That's the first difference. The second difference is that when parents make these choices without being able to ask their children's consent, it is the best of the worst options when we're talking about something that's going to have high morbidity, high mortality for the child in question. We have to act now. It's an emergency. It is not the desirable decisional space to be. And indeed, if there is an instance where you could wait and allow your child to reach a level of maturity, we would say it's better to engage that child in such a significant decision for that child. So to me, when a somatic edit is as safe and available, why wouldn't we ask children whether they want the edit or not? Why wouldn't we engage them in this decision? Now again, it's a presumption. There may be instances where it is not available, where there is a real risk of waiting. But when it is available, it seems to me we should ask each of us to make our own decisions about our own lives, our own destinies, and our own genetics.
To be fair, counter rebuttal.
Well, I think that baby KJ, who's the newborn infant that we're talking about here, I don't think the infant consented, right? I think it would be silly to think that. So that's why the ethical framework expands to embryos. Not only that, I think families should have the choice. It's about the choice of having the option to correct the genome of their children. And if that's something they want to get rid of in their family, they should have the option to do so. No one's coercing them. But taking that option away when the technology could be ready for them, I think that is a form of coercion on its own, and it's pretty unethical. So to say that, you know, the great-great-great-grandchild will have a mutation that they didn't consent to, or, you know, a mutation corrected that they didn't consent to, the opposite is also true. The benefits can also compound, and they'll be thankful that their great-great-great-great-grandparent did that, so generations later they didn't have to suffer in that disease.
Wow, thank you. Moving on to the next question. We saw some disagreement regarding what would justify the use of gene editing in reproduction. But just like the two of you disagree, there is also wide disagreement amongst ethicists, scientists, and the public. What should we do in order to reach an appropriate level of social acceptability before starting clinical use? Do we need to reach global consensus, broad agreement at the national level, at the community level? And how should this be done? Who gets to decide? Should governments regulate what kind of edits should be permitted, and how might that be carried out? And this time, Kathy goes first.
First, the proposed consensus on a bioethical question is something we should stop pretending is realistic. We did not have consensus on IVF in 1978. The Pope opposed it, feminist scholars opposed it, disability advocates also objected. Today, roughly 10 million people are alive because of it. We didn't have consensus on the first heart transplant in 1967. Critics called it playing God. Some called it grotesque. It forced society to redefine what death itself meant. Today, open heart surgery saves roughly 2 million lives every year. We also didn't have consensus on Jenner's smallpox vaccine in 1796. There have been organized anti-vaccine movements continuously ever since, but today, smallpox has been eradicated from the face of the earth. If we had waited for consensus in any of these cases, we would not have had these technologies today. The right standard isn't consensus, it's legitimacy. And legitimacy is built from data, transparency, informed participation, and accountability. Which brings me to the missing piece of germline gene correction as it stands today. The reason why I cannot answer safety concerns with data is that we have been prevented from generating this data. The federal restrictions that make this research unfundable in the United States have been in place for over a decade. The appropriations rider that prevent the FDA from even reviewing germline applications have been renewed every single year since 2015. The Dickey-Wicker amendment blocks NIH from funding embryo research that would generate the safety data. In practice, only a handful of US laboratories have been able to do this work at all, and I've actually spoken to multiple of them personally. So there is a structural problem that we should name plainly. We're told that the science is not ready, that the same system has prevented the science from being ready. You cannot put a technology in a regulatory cage for 15 years and then point to the cage as evidence that the technology is unsafe. On who decides, germline editing is embryology-based, so the pathway has to be adapted, not invented from scratch. The FDA already regulates gene therapies, already regulates IVF and pre-implantation genetic testing, PGT. A germline pathway combines these existing frameworks with a modification appropriate for heritability. The sequence is one I described earlier: preclinical data first, patient-derived iPSC validation, research embryo studies within the 14-day rule, off-target and mosaicism sequencing, and later on clinical trials to establish safety and efficacy, then clinical use with longitudinal follow-up, sequencing, and observation over decades. The bar is the same bar we apply to any serious medical intervention.
Glenn.
So I love this slogan, not consensus, but legitimacy. I think I agree with the slogan, but we might mean something slightly different by it. And here's what I mean by it. You mentioned mitochondrial replacement techniques. I think that's a very good model for what I'm thinking of ought to occur. Not merely the FDA process, but an engagement of the public. In the MRT case, the Archbishop of Canterbury had op-eds. It was debated in Parliament. In Singapore and elsewhere, we've seen ideas like deliberative democracy experiments, citizen juries, and the like to educate people. I want to see a widespread public engagement and ultimately legislation and debates in the highest halls of government across the world on this topic. I want the people to be heard, and to me that is a prerequisite, this kind of engagement, for any of this kind of work. Even after that occurs, my own view is this is not a space merely for market actors to behave, but we ought to have, and we might agree on this, I'm not sure, as the NSAM suggested, there ought to be a regulatory body that does a case-by-case review of every proposed edit. Besides evaluating the safety of individual uses, there should be verification of full informed consent of all parents. Decision-making is informed by findings from independent international assessments of progress in scientific research, which indicates that the technology has advanced. The details of the approved applications, including genetic conditions, laboratory procedures, clinic conditions, are made publicly accessible for all of us to look at, not merely for the regulators. Monitoring the long-term follow-up of these children who are born generation by generation, where possible, publicly sharing the data in a way that would not identify the individuals, and having this research published in peer-reviewed scientific journals. So I want to see both the public engagement on the one hand, but also the governmental engagement on the other. And I think in some ways something like the HFEA in the UK, which has licensed mitochondrial replacement technique by clinic, by application, is appropriate, because there may be some applications that are appropriate and some that are inappropriate, and I think all of us have a stake. For sure, the affected communities, the people with the diseases, have a stake in this. But when it comes to the human genome and gene editing, we all ought to have a voice, and I want us all to be engaged.
Kathy, what do you think about what Glenn said?
I think on a technology level, I agree. But from a level of governance, I have to call out what is actually happening. I think it's great to have idealistic standards on global collaboration, NASEM, things like that. I think it's great, but in reality, what has it actually done in the last 11 years? As I said, there's a lot of papers published, a lot of great reports, a lot of gatherings in beautiful cities, but zero approved therapies. And I don't see anything changing if we just keep citing these acronyms and these idealistic standards. So I hope that something can change, and I think, again, the missing piece is science. So I'm glad that we agree on how to get there from the technology level. I think a key part of this is actually longitudinal studies, because when IVF was first invented in 1978, the person who invented it didn't even get a Nobel Prize until he was on his deathbed, because they had to do 2 generations of observation of the children born through IVF. I do believe the same standard should apply for germline gene correction as well. So I think this technology should be held to a very high standard on the technology level, but I think from a governance and bioethics level, it needs to catch up.
Rebuttal or move
Sure.
on?
I'll do a quick one, which is to say I'm more optimistic in part because of the story of mitochondrial replacement techniques. As Kathy said, in the US, not available. In the UK and elsewhere, is available. The result in the other places, not in the US, of the kind of public engagement I'm talking about. And I would never think that I would be the person to stand up and defend Congress, and I'm only going to half-heartedly defend our Congress in the United States. But the appropriations rider we have in place right now is the result of a kind of political process, a kind of engagement by the public. And my view would be the best way to do this is to engage the public in saying why it's wrong, to educate the public as to say why there are compelling cases where exceptions ought to be made. And once again, as I started by saying that I thought the policymaking here is too coarse, to arrive at opportunities. But It's much easier to assure the public that we can have fine-grained distinctions and we can have expert reviews when you empower government to be the one doing the review on the back end. And that, again, is the UK model, the HFEA, where we have an authority who is responsive and responsible to the people, not to venture capital, not to the market, but to the people who gets to make the determinations. And you know what? If you don't like it, throw the bums out, as they say. And that is the kind of engagement I'd like to see in this country. And the fact that it has happened elsewhere on mitochondrial replacement techniques gives me some hope that it'll be possible even here in the United States.
Thank you. I'm going to ask you my last question and open it up to questions from the audience in the room and online. People online, it would be, I encourage you to post questions already now because it'll be difficult for us to read them all at the end. So feel free to intervene at this point. My last question is this, and it's a sensitive question. Do you think that using gene editing to prevent certain conditions could be ethically problematic because it would send a hurtful message to those living with us with those conditions? Could it be seen as eugenics? Some disability rights advocates have argued against the use of this technology, especially in the context of using gene editing to prevent heritable deafness that is considered by many not to be a disability, but rather a difference. How would you address these concerns? Glenn, you go first.
Okay, boy, sure, an easy one. So I'll give the cop-out answer, easy answer first, and then I'll move to a harder answer, right? So the easy cop-out answer is deafness does not qualify for the criteria I've described about serious monogenic disease. So it's just out, at least for the time being. Now, of course, if I was a student in my class, I would push them and say, okay, Mr. Cohen, well, what about 20 years from now or 30 years from now? Could you possibly imagine a world where this is possible? And I'm very sensitive to the slogan, nothing about us without us. I'm not a member of the deaf community, and I don't feel comfortable speaking on behalf of the deaf community. And the reason I emphasize that is, again, with this idea of public engagement, part of what I would want to know is, how does the deaf community feel about this topic? Do they feel as though this sends a signal that this is not a choice-worthy life? Do they feel as though this sends a signal that they're not a life and a kind of experience worth having? I also think about this a little bit in the context of my own community. I am gay, and I don't want to speak on the gay community, but I could speak a little bit about this. That if you were to ask me if parents wanted to have gene editing to eliminate homosexuality, would I be okay with that? And can I articulate why that is or unlike eliminating deafness in a population that celebrates, for many people, being deaf and deaf culture? And would we allow people to make a choice not just for their children, but for their children's children, and whether these communities ever exist in the future or not? I think choosing against deafness is, I think, correctly, broadly understood as eugenic, but labeling it as such does not solve the hard normative questions. In the ART PGT context, some have spoken about liberal eugenics, saying that the concern about the Nazi eugenic program, for example, was that it was imposed upon people. But as long as we're letting people make choices, that's something very different normatively and ethically speaking. But I want to emphasize that these are not choices that are unfree or free in some normatively ideal sort of way. They are choices that are constrained by markets, by the availability of technologies, and also whether we have a society that is designed to accommodate people with these lived experiences. It's also a choice that has expressive and practical consequences for the community who's chosen against. And the fact that we're talking now not about sexual reproduction, but a new technology, my own view is that their seat at the table is a very big seat. Whether it's a veto, I'm not sure. But it's certainly a community that I think would have to be engaged. And for the foreseeable future, I don't see this as in bounds.
Kathy.
I heard something get brought up, which is that there's factors like markets that make this access unequal, and that is one of the reasons to not pursue this. I think that's fundamentally an intellectually lazy argument to load the full weight of this problem onto...
I don't think anyone ever called Glenn before.
It's okay. No, let her finish. We'll talk about it.
Thank you, Kathy. You're making it more fun.
That's what I do. I think to say that, even if this is approved and it's a choice that families have, what I just heard is, even if it's choice, it's still not fully an equal choice because some people will be influenced by the markets to have that choice or not. That's what I heard. We can play the tape back if we want to. But I say that's an intellectually lazy argument. I think we are putting the full weight of this problem onto a nascent technology of access. The problem involves insurance, governments, pharma, healthcare systems. I've worked in a lot of these fields too, and to load the full weight of the problem onto a nascent technology like germline gene correction that did not even cause this problem to begin with, and cannot solve it alone, I think that's intellectually lazy. That's just on that note. But on the other question, which is the actual question that I need to answer, I don't think that this is sending a hurtful message. It shouldn't send a hurtful message to people living these conditions. And in my mind, it's sort of like saying to a cancer patient, hey, you cannot get chemotherapy because it sends a hurtful message to another cancer patient that you get chemotherapy. There's value in your disease. I think that is silly and hypocritical. And if we apply that framework onto germline gene correction unfairly, we're ignoring the rest of the medical field that currently falls under, currently operates the way that it does. And I think that whoever wants that treatment should be able to get it. There should be a choice. There should be no coercion whatsoever. Eugenics, on that note, is a very heavy word as well, and I would prefer to stop throwing that word around when there's no bioethics basis for that. This is a treatment, just like any other treatment you can get for your newborn, like baby KJ's case, or for an adult, or a normal pharmaceutical product. Eugenics is when the states coerce individuals to make certain reproductive choices that they didn't want to make. This is not that. No one's going to force anybody to get this treatment. They would only get it if they want to. And that goes into kind of the next point about deafness. Again, I think we live in a democratic society. If people want to, eventually, when this technology becomes available, it doesn't fall into the same, under the first monogenic disorders that we'll be tackling, but eventually when this becomes available, people can choose if they want to pass down that trait or not to their children via germline gene correction. So again, it's all about choice. It's about democracy. And ultimately, it's for the patients. It's giving them more choice and freedom.
Thank you. Wow. The official part of the debate is over.
Can I say one word?
One word.
Okay, one word just to play the tape and turn it up. Is the idea here that we're talking about making choices against a background of a real world. And a world that honors deafness, a world that creates space for deaf people is very different from a world that eliminates them. A world that compares deafness to cancer is very different than a world that acknowledges deaf culture. I think that's important to say that.
Okay. Before you put your boxing gloves on, we're talking about the real world, and we have with us in the room a couple, Asaf and Nicole, who live in the real world with a genetic variant causing disease that could, in Kathy's world, be candidates for gene editing. And Nicole, we want to hear your perspective on everything that you've heard so far today.
Thank you. Sorry, Glenn. Earlier you said a really good thing, and I'm going to get upset. Sorry. We've been at this for 3 years now. We've had multiple embryo transfers. Oh.
Do you want to bring her up?
Is it on?
So everyone can see?
Yeah.
Do you want to come to the podium?
Yeah.
Sorry. Ooh.
Okay. Glenn, you said earlier what we own with children. I can personally say, as a third generation of my disease, I owe my children not to pass it on. My disease causes cancer, and there is no cure for it. It's just preventative invasive procedures every 6 months to every year on every type of my body, blood tests, everything. So for me, it's a case of if I cannot pass that on, I know my mother wouldn't have passed it on, I know my twin sister doesn't want to pass it on, and I know my grandfather wouldn't have passed it on. So as much as we can say within the debate, we're not, for our future generations, I would have this, if Kathy tomorrow said, hey, look, here's your embryos, we'll fix them, I would take it. We've been at IVF now with PGT for 3 years. And they are invasive procedures. The amount of injections I've had, I have to have 4 injections every day for 15 days just to do a retrieval cycle because I have other conditions which add to it. And I can tell you it's painful, and the bruises it causes is horrible. So if I can get double the amount of embryos that we get, because my condition is dominant, it will only give me half of what we end up getting, or even less than that if the biopsies, unfortunately, end the life of the embryos in itself. So out of, 40 embryos, we only got 8. in the case of the last 3 years that we could use viably. So if I could get even a touch more of those, we would by now have our first child, we'd probably be on to the second child. And I would be having to stab myself a lot less than I do now. So I am all for this treatment, and I can say that we're the lucky ones, we can choose PGT. I know a lot with my condition don't have that option, and they just have to do it naturally. So for me, we are lucky, but we're also not lucky at the same time. So I am full for this, and even if it's me making the decision for future generations, I will make that happily without a moment's thought. Thank you.
Thank you.
If I just add one more thing about future generations, we're always talking about the future generations of the embryos that have been edited. What about the embryos that never got to that point because we had PGT? We chose not to use them. You could say, oh, we did make that choice for those future generations. I think that's, for us, like Nicole said, an easy choice to make. I don't want to live with the guilt of having to pass that on. And I think that those should also be taken into account, and we would have to live with it, and I'm sorry.
Yeah, basically, there are so many embryos that could have had a life that we chose not to give a life, so it's the opposite as well of they could have been a living, breathing human if they were healthy ones instead of, unfortunately, unhealthy ones.
Thank you both. Thank you. Thank you so much. Wow, we need a moment, but I'm so grateful that you're here in the room with us, because we talk about public engagement, we talk about real world. Your voices are critically important in this conversation, and Glenn was hoping himself that your voices would be around the table, so we're all grateful that you're here. Okay, we have 1 minute to the end of the online event. The privileged audience in the room can continue the conversation, but I'm going to go all Blair on you and ask each one of you for a 30-second take-home message for our audience. Kathy, you go first.
Sure. Well, I think that there is an emperor wears no clothes quality to this debate. The people inside the field are sometimes too afraid to state the obvious. And I think that's partly why I'm here tonight, because sometimes we need somebody from the outside to say the simple things. So here are the simple things. Whether we agree tonight or not, this field is going to move forward. It has been inevitable from the start. The only open questions are how, with whom, and under what conditions. The technology is real, the families are asking, and delay does not make the safer, only research does. If we want to be ethical, we have to do the science, openly, with oversight, and with the patients and carriers in the room with us. Thank you.
Glenn, can you beat that?
If the emperor is naked, I don't want to be ruled by them. And essentially, what I really want is a world where we all participate and we make decisions about this collectively. And I reject the idea that the technological imperative is inevitable, that this is going to happen whatever we say. Instead, I believe that we can come together and we can make decisions about what rational regulation in this space should look like, and we all deserve a seat at the table.
Thank you.